Hello, welcome to my channel. Let's now discuss the first topics in physics, that is units and measurement. I wonder what my weight, or more accurately, my mass is. Let's measure it, and I will use my bathroom scale here. So here I have a bathroom scale that I'm going to use. It is powered by, you step on this, I think it's a spring. So I'm going to use my weight. Okay, so it's about 90 kilograms. So if we want to know something, you have to quantify it. It should be quantifiable and it should be measurable. So in our case, I was able to determine a quantity with a unit. So the quantity there, the number is 90, and then the unit is the kilogram. So it says something about my mass, my weight. Okay, so let's measure something else. Let's measure I have a ball here. A diameter, a diameter of a ball. Let's measure the diameter of this. So when we measure something, we have to compare it with a standard. I have a standard here, and our standard here is a ruler. So let's measure it. So if you want to measure something, we compare it to a standard. In this case, let's say we'll put it somewhere here, okay, somewhere like that. So it should be at the zero, or we can determine it later. But take note that when you measure something, if you look at this here, the diameter of this will become shorter. But if you look at this here, the diameter becomes longer. So it is very important that we avoid an error in measurement that we call parallax error, wherein you're not measuring at the proper eye level. So what you can do, perhaps you can add something like this, a book, to make it at the same or at the same level to avoid parallax error, same as here. So that's how we do our measurement. We compare it to a standard. Okay, so now let's measure my heart rate and perhaps study the electrical activity of my heart. So I'm going to do that using a stopwatch. Oh no, the Apple Watch, I mean. The Apple Watch, it has an EKG sensor and some electronics on it that we can use to measure my heart rate. Okay, let's do this. So here I have my EKG sensor. So let's now measure my heart rate and the electrical activity of my heart. Let's do this. Wait. Okay. You have to hold it properly. Mhm. Okay, so I will try to do it again and do some trials. Okay, so earlier we did some measurement and my weight or my mass is 90 kilograms, and we also measure the diameter and some ray tracing. So I already finished my ray tracing, and let us let us transfer my data here to uh, my iPad here. So I was able to get my heart rate. Let's call it, yeah, the heart rate. The heart rate is 54 beats per minute. So it means that my heart is beating 54 times every minute. Now, if you're going to analyze this ray tracing, okay, so how about the period? If we're going to analyze this, look at this. Let us analyze this part here, and one cycle of a beat of my heartbeat, that represents one cycle of the electrical activity of my heart. So here it's somewhere 0.8, and here it's somewhere in between. It's not 2, it's not 1.8, but I think it's 1.9. Okay, so this is 0.8, this is 1.9 second. So now if you're going to analyze the period, let us compute the period of my heart rate. Okay, so the period is equal to 1.9 second minus 0.8 seconds. Or you can say it's about, okay, wait, 1.1 second. So that is now the period of my heart rate. It means one beat is actually 1.1 seconds. So now we measured the time. Okay? So as you've noticed here, measurements has such an impact in our lives, and it is, for example, we can use this for just determining our weight, measure the diameter of the ball, or even in medicine. So the cardiologist can actually get a lot of information from measuring the electrical activity of the heart. Okay, so for example, this wave, they can actually diagnose a patient. I am not a doctor or cardiologist, but from from this tracing, this represents the electrical activity of the heart, the contraction of the different parts of the muscle of the heart. So sometimes they can assign some parts here, the P, Q, R, S, T wave, and that represents the heart. Okay, so this represents the heart. So now let's proceed to the units. So let's now discuss units. So what are units? Units is actually used to describe a quantity. So it describes a quantity. Okay, in our example here, we have 90 kilogram, we have 54 beats per minute. So in a way, these are the units. And for the period of my heart, that's 1.1 second. And we also did some measurement. Let's say let's say the diameter of a ball is, let's say the diameter of the ball is 20 centimeter, just an example. Okay, so these are your units, the second, centimeter, kilogram, and the beats per minute. These are your units. Now, there are different types of units, but there is an accepted units, and that is agreed upon by basically the whole world, you know, and that is the scientific units, and that is the Sistema Internazionale di Unites. Okay, so here you have your quantity. For example, the length, you have the mass, and you have the time. Okay, so the SI unit for length is your meter. For mass, your kilogram. And for time, of course, second. We also have other set of units. If we're dealing with smaller quantities, we also use this one. We call it the CGS unit, CGS system. Okay, so let me correct that. And for length, it is centimeter. For mass, it is in grams. And then for second, yeah, of course, for time. So CGS, centimeter, gram, and second. Now we also have some units in the British engineering system of units. For length, we use the foot or the feet. For mass, they use the slug, which is quite weird sound, SL. And for time, good thing is time is the same. So we don't have to worry about converting this because it's the same for time. Okay? Now these units sometimes can be very, very huge or very small. So sometimes we use unit prefixes. Unit prefixes. Okay, what are those prefixes? So let me write it in a smaller font. So for example, you have a table here. So let me use a white color. Okay, so you usually have some factor. Let me write it. So you have a factor here. And you have the prefix. Okay, so for example, you have a quantity that is 10 to the 12. We call it, the 12, we call it the tera, capital T. Let's make it larger. The tera. If the quantity is in the range of 10 to the 9, we call it giga, okay, capital G. For quantities that are 10 to the 6, what do you think? It's mega. The prefix is mega. For 10 to the 3, it's kilo, K. And so we have the basic one. Okay, 10 to the 0 is 1. Now for smaller quantities, you can also have 10 to the negative, for example, 10 to the negative 2. And that is centi. Okay, 10 to the negative 3, that is a milli. 10 to the 6, these are smaller quantities now. Micro, so talk about bacteria here. 10 to the 9 is nano. Okay, and there are still smaller quantities, especially in physics. 10 to the 12, that's pico. The symbol is small p. So what are the examples of this? Example, I don't know, for length, example, length. So how do we denote? So the basic unit for length is the meter. Now, if we're dealing with larger value, so 1,000 meter is actually 1 kilometer. Okay? Now, for smaller values, let's say 10 to the negative 2, that's centimeter. So we use cm. For milli, we use millimeter. For micro, micrometer. In smaller quantities, nanometer and picometer. Now, for example, our memory of our computer, memory which is actually in bytes. So a long time ago when I was, so we have the bytes, when I was still in first year high school, you have to be, you are very glad if you have a diskette. A diskette has a storage capacity of about kilobytes. Okay, and now when I was in college, wow, if you have a 2 megabyte USB, wow, like all your classmates will be, oh my God, you're rich. Oh my God, you'll have a lot of friends. And now we're using gigabytes to store memory. GM, oops, GB, I mean GB. Okay, and now for even more higher memory, no? So we have terabytes where we save our backup files. So these are the examples of quantities and their prefixes. You see, we just use T for tera, and then K for kilometer, and for smaller quantities as well. Okay? So let's now discuss unit conversion. So earlier, let's have unit conversion. So earlier we have 1 meter. Now what it is in centimeters? So it is 100 centimeter. Okay? Now if you're going to write it in scientific notation, it's actually 1 times 10 to the negative 2. Okay? Meter, or 1 times 10 to the 2 centimeter, 1 meter. Okay, so this is 1 times 10 to the 2 centimeter in scientific notation. Scientific notation. How about what is 1 meter in millimeter? 1 meter is equivalent to 1,000 millimeter. So you can write it in scientific notation as 1 times 10 to the 3 millimeter. How about micrometer? Micrometer is even smaller. 1 million, 1, 2, 3, 1, 2, 3 micrometer. So it's now hard to write lots of zeros. So that's why it's better to use scientific notation. 1 times 10 to the 6 micrometer. Okay? And still you can have a even smaller, but it will be harder for you to write in terms of nanometer. 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh my God, so that's a lot of zeros. Or better, write it in scientific notation. 1 times 10 to the 9 nanometer. So these are your unit conversion within a unit, like within meter to centimeter and to millimeter and so on. So now let's discuss unit conversion. Okay, so let's discuss some common examples of unit conversion. Okay, so in the US, they use mile. So for 1 mile, in Manila, in the Philippines, we use, of course, kilometer. It's actually 1.609 kilometer. Okay, how about what else? In the US, they use foot. 1 foot is equivalent to 0.3048 meter. Yeah, and then of course 1 yard in the US, it's actually equal to 3 feet. Now what is this in meter? So let's try to convert that. Okay, so what is 1 yard in meter? 1 yard, you multiply it by its factor. So for 1 yard, there are 3 feet, but look, 3 feet, 1 feet is 0.3048 meters. You can also multiply it by, for 1 foot, 1 foot, 0.3048 meter. So here, what you can do is you can cancel out some quantities. You can cancel out yard. Here, you can cancel out, this should be feet. You can cancel out feet. So what you will left will be the meter, this one. So 1 yard is actually equal to, now, if you're going to use your calculator, I think you should get an answer of 0.9144 meter. Okay, so you can have another conversion factor. 1 yard is also the same as 0.9144 meter. How about for volume? For volume, it's actually equal to 10 to the negative 3 cubic meter. So meter times meter times meter. The other quantities for power, 1 HP, horsepower. This is the unit that we use for the power of the engine of cars and airplanes and buses. Okay, and so that is equivalent to 746 watts. Okay, watts is the unit of power. Okay, and for let's say another unit here, 1 inch, that's equivalent to 2.54 centimeter. Okay, now let's have some example problems on my next video.